Date is 2/20/14. Dividing polynomials, right? Then it has a semicolon and then rational expressions. Okay, first of all, let's review what you're going to need for this section. And I'm going to label them A, B, C, and D, okay? When you have something like this, you're going to need to be able to realize that what can I factor out of this? I can factor out an A, right? You're going to need to be able to do something like that. We have factored things out. A greatest GCF, right? We factored out GCF there. You guys remember doing that? Also in this chapter, when something was in this form, a squared plus 2ab plus b squared, we have factored that to a plus b quantity squared. When something was in this form, a squared minus 2ab plus b squared, we factored that into a minus b quantity what? Squared. We've also done where something was in this form, a squared minus b squared. We factored that into a plus b times a minus b. See, we've dealt with a lot of different types and we've factored them. We've also dealt with a to the third plus b to the third, and we saw that factored to a plus b, the quantity a plus b times a squared minus, is it 2ab plus b squared? And we also a to the third minus b to the third, we saw that factors to a minus b times a to the second minus, or I'm sorry, in this case plus 2ab plus b squared. We've dealt with all of those. I'm sorry, it's not 2ab, it's ab. I thought that was wrong. I apologize there. So don't put 2ab here, this is ab. Everybody got that? Okay, so we're going to refer to these and basically say, okay, hey, I think I got something like A, I got something like B, I got something, because what we're going to do is we're going to divide two polynomials and we're going to kind of cancel out the things we can't. And I'm just going to start with some examples. For instance, in the book, it's going to say this divided, and use the divided by sign. I want you guys to put it over. So if they gave you something like this, don't write this down yet. Y to the fourth divided by 2y to the fifth. Instead of writing it down like this, when you guys write the problem, write it like this: y to the fourth over what? 2y to the fifth. Okay? Now, when you have ones like this, where there's no factoring or anything to do, these are pretty easy. Okay? And so we'll start with one like that. But the rest of the problems, I'm just going to start out writing them like that. I want to go with one a little different than that. How about we go 25 x to the 5th over 10x to the 3rd. Now, I don't think there's any factoring to do here, is there? What's the difference between this and all of these up here I gave you? There's just one term, isn't there? All of these have more than one term, don't they? This form, you know, if it looks kind of like this. So here we just see if there's some things to reduce. My advice to you is think of this like this. Because really, you're just multiplying two fractions. One's with numbers and one's with what? Variables. You guys see that? First of all, how would you guys reduce this fraction? See what a common factor is, wouldn't you? What's a common factor of 25 and 10? 5 will go into it what? 5 will go into that what? 2. Now, kind of a note off to the side on this. I think you guys need to realize, and in my opinion, so we'll change this to 5 over 2 times. What I've always told people is write this, but it'll help you so much when dealing with these type of problems if you see this. Because isn't this what that means? Does everyone agree? Isn't this what that means? Because I think it helps, because then you can say, okay, what cancels and how many are left where? Well, these 3 on the bottom cancel with 3 of the 5 on top, leaving how many where? 2 x's on top. So when I'm writing it down here, I always put a whole mark through the whole thing to say those are all what? Gone and divided into 1, right? But then I put a mark through just the 5 and said how many are left over? 2. Does that make sense? See how I did that? So when I'm writing this, I know that what's left on top? 5 and what? X what? Squared over what's left on bottom. You guys okay with that? Any questions on that? Do you guys think you can do those? Those are pretty easy. Well, maybe we do one more. And do it without, you know, breaking it down so much. Let's go, how about 4 x to the 3rd y to the 2nd over 16 x y. Or no, x to the 5th y. How about that? Make it a little bigger so it's easier to see. Okay, first of all, let's deal with the numbers. Is there a common factor between 4 and 16? 4. 4 will go into it what? 4 will go into the 16? So it kind of reduces to 1 over 4 there, doesn't it? Now let's look at the x's. I have how many on top? How many on bottom? So how many are left and where? There's 2 left, but tell me where. Because there's 3 on top, they all go, but there's still 2 left down here, isn't there? Makes sense? Put that up. Now here, when we don't have an exponent here, what is this? Y to the what? Right? So I've got 1 y on bottom and 2 on top. How many are left where? 1 on what? Top. So what's left on top? There's a 1 times y to the 1st, so this becomes what? Just a y on top, right? What is left on bottom? 4 times... Not so bad, is it? Okay. The majority of your problems are not going to be like that. I probably actually don't like that fact. The majority of your problems are going to be ones that are like the ones I showed you up top. How about we start with 4x squared minus 2y, all of that over 8. This is one of the more simpler ones. But because I've got a binomial up top, I can't like say the 4 and the 8 cancel right now. Okay, you can't do that until it's one term. And the way you make it into one term is, I know this sounds crazy, but if you think about it, isn't this right here basically, doesn't it kind of become one big multiplication problem when you factor it? Isn't that just one big multiplication problem once I factor it out? It's this times this. Now you can start reducing. So I need to see if there's anything to what? Factor here. Is there anything I can factor, a greatest common factor of this term and this term? Look at the numbers. Is there a number you could factor out? So 2 factors out. 2 will go into both of them. Did it have any variables in common? No. So now it's time to write what's left. 2 times what is 4x squared? Well, 2 times what is 4? 2 times 2, right, is 4. Everyone agree? And then to get x squared, I have to say times 2x what? Squared. 2 times what is negative 2? Negative what? 1. And what do I also have to have? Y. Now, multiply back through in your mind. You get the same thing? You get it right. All of that over 8. Now what can I do? Since I've made it into a multiplication problem, now I can start reducing. Look at this and this. 2 goes into 2 what? 2 goes into 8 what? So now, if I multiply back through times 1, I'm just left with this, aren't I? And that is your answer. Questions on that? Any questions there? It's not too bad, is it? Well, as you would imagine, they're going to make some things that are a little uglier, like x to the third, y to the fourth, minus 2x y to the second over xy. That's just plain ugly. Okay? Well, when I'm looking back up here at these, the only thing I could probably do, I don't have like a to the third plus b to the third, do I? Because this is to the fourth, that's to the first. I probably have, my only chance is probably to factor something out. What could I factor out? Do they have any x's in common? There's an x in common. What's the most amount of y's in each one? So y squared. So now you just got to say x times what is x to the third? X to the what? Second. Y to squared times what is y to the fourth? Y to the second. See how when you multiply back through you get that? Minus, you got to have the 2. 1 times 2 is 2. X times what is x? X times 1, so that stays there. And then y squared, that's actually all that's left in there, isn't it? Because that's exactly what I pulled out right there. All of that over xy. Now, since I've made it into one big multiplication problem on top, I can see if there's anything to cancel or divide into 1. What cancels here? Both the x's just both cancel out, don't they? How many y's are on the bottom? How many does that leave then? Leaves just 1 up here, doesn't it? So my answer is there's just 1's left on bottom, so it's y times x squared, y squared minus 2. And just leave your answer just like that. Write that down. I mean, you could multiply back through if you wanted to, but I don't see any reason to. writing down notes? Now, we're also going to have some up top when you guys get done writing that down. It'll actually look more complicated, but be easier. And there's a reason why I didn't want to give any makeup tests or anything today, because you guys need to listen to this. This isn't that bad, but it's we're just, something we're going to spend a little time on. Basically, give you all day tomorrow to work on it. Everybody about got this all down? All right. All right. First of all, does our top look like anything on the left here? Really doesn't, does it? Looks like something on the right, but basically that means it's already factored. What does A plus B quantity squared mean? It means A plus B times what? Both of them in parentheses. All of that over A plus B. Do you see anything that can cancel there? Does this A plus B cancel with that A plus B? Dividing into 1, leaving just what? On top. And there's your answer. If it had been left on bottom, it'd be 1 over A plus B, right? But it was left on top.
What was the point of that?
To show that these divide. That if you have 2 of them, it's the same as saying when you have x squared over x, x times x over x. Look, they divide. There. Now, however, unfortunately, you're going to get some like this. Let's make this 8. Here's what I want you guys to look at on this problem. You're going to get some problems that they're going to require you, and if you'll open your books to page 163, 9 through 20, your directions are factor the numerator. What's the numerator, the top or the bottom? The top, right? Factor the top, then look for a common factor. Basically, you're going to, when you factor the top there, it's going to factor like one of these. So you have to figure out, do I have one like A? Do I have one like B? Do I have one like C? Do I have one like D? Do I have one like E or F? Looking up here, which one do you think you might have one like here on the top, right here? Does it have just 2 terms? Does it look like, like this up here, where you're going to factor a common factor out? I could factor out a 4, but I'd still have 3 things left. And I need it to look like that, so no. Does it kind of look like this one, though? Like you've got a perfect square here, a perfect square here, and 2 times A times B in the middle. Does it look like it? Well, see if it does. What would A, if this was, what would be in here? 2x? Would you agree with that? 2 times what times what? What's A? 2x, and B is what? 2. Does this look like this? Would this come out to be this? Does it? So you have one in this form right here, don't you? So you know that it will factor to a plus b quantity squared. So what was your a? 2x, right? Plus, what was your b? 2. All of that squared. Over, what's on the bottom? 2x plus what? So this was just like the problem we just did. Please sit up. We are not going to sleep. Wake up. Ashley, wake up. Sit up, please. Would that not cancel there? Your answer? 2x plus 2. Write that down. All of these problems are going to be in one of those forms from B down on numbers 9 through 20. So you have to start making yourself familiar with those. And figure out what your A is and what your B is. Be able to break it down like this and see that that's 2x squared, right? That's 2 squared. So A would be 2x, B would be 2, and see if the middle one is 2 times A times B. If it is, it's in that form, and it factors to that, just like it does up here. You guys can do that. You just don't want to. You don't want to have to think. This is not the first time you've ever done this before. The next one, number 7, I want you to look at this, and tell me what type is it like. Does it look like, does it have a chance to be like number A? Like A? Yes or no? Do you think it looks like A? And to be honest, on 9 through the ones we're doing now, we're not even going to be using that one. What do you think it looks like, guys? Look at number 7 on the top. I've got 8x to the third plus 27. Does it look like B, you think? Does it have 3 terms? So could it look like B? No. Okay, so say no where I can hear it, please. I'm old. What about C? Does it look like C? How about D? D is what? A squared minus B squared. Does that look like it could be something squared minus something else squared? There's a plus in between them, and it's to the third, isn't it? Does it look like there's a chance it could be like E? Something cubed plus another thing cubed. There is a chance of that, isn't there? So let's see if we can figure out what the A and the B would be here. In other words, figure out what goes in the parentheses. Haven't we done this before? Didn't we do this in 5.3? Okay, let's figure out what would be in the, what could I multiply times itself 3 times and get 8x to the cubed as an answer? What about the numbers? 2 times 2 times 2 is 8, right? What times what is x to the third? So now I figured out what A is, haven't I? Right here, 27. What times what is 27? 3 times 3 is 9, times 3 is 27. So now I figured out what A is, and I figured out what B is. So I'm down here. Now I go over here, and on the top, I simply what? Fill in the appropriate thing. A is what? 2x plus B, what is B? 3. In here I have whatever A is. What's A? 2x, and I square it. Minus whatever A is. What's A? 2x times, which is B, plus whatever B is, which is 3, and square it. All of that over 2x plus 3. What ended up happening? Was there a common factor? Something I could cancel out? Right there, right? So your answer is that cleaned up. What is 2x squared? 2x quantity squared. What is the answer? Nope. 4x squared, because you have to square the 2 too. What is the minus, what's 2x times 3? 6x. Plus, what is 3 squared? Now you divided them, and there's your answer. We're going to go over your assignment now and look at every single problem. Everyone turn and look at number 1. Is there anything to factor there? On page 163. Everyone needs to have their book open at section page 163. Well, it doesn't look like any of these, does it? So there's no factoring to do there, right? You just divide, right? Would everyone agree? Number 2, is there any factoring to do there? It's like A, isn't it? Where there's a GCF to factor. Would you guys agree with that? On number 2? So you're going to factor out a GCF. Number 3, what does it look like? Is there any factoring to do on the top? Which one does it look like? A, B, C, D, E, or F? Number 3. From your book. This one right here. Well, it's not anything squared though, right? Because the pi's are the same. Does it look like you have some things you could factor out? They have pi's in common, right? And they have an r in common. Could you factor out pi r? A GCF? So it's more like A, isn't it? You're going to factor out a GCF. Number 4. What are you going to factor out there? It's like A again. You're going to factor out a GCF, aren't you? With the numbers, it's 2. With the variables, it's x to the 3rd, isn't it? Do you guys agree? So you're factoring there. Number 5. Is there any factoring to do there? Is it already factored? Look at number 5. It's already factored, so there's no factoring to do there. Number 6. Is it already factored for you? No, it's already factored. How about number 7? It's already factored for you, isn't it? How about number 8? It's already factored, isn't it? So now we get to different directions. On number 9, it says factor the numerator, then look for a common factor. So obviously they're going to want us to factor, aren't we? So this is the main one where we need to figure out whether we have one like B, C, D, E, or F, right? So look at the form of what you have on top. On number 9, what looks like our possibilities? B, C, D, E, or F? Well, first of all, how many terms are on top? So obviously these 3 down here aren't going to work, right? So it's either B or C, isn't it? Look at the signs. Which one could it be, B or C? So you know what to look for there to see if it fits, right? Number 10. What does it look like? There's 3 terms, so it's either B or C, right? B. It's probably going to be like B. Number 11. There's 3 terms, so there's a chance it's like what? B. Number 12. There's 3 terms. Which one do you think it's like? So you're going to need to figure out what your A and your B is there, right? Number 13. Which one is it like? Oh, there's only 2 terms here, so I'm kind of dealing with these bottom ones, aren't I? It's like E, isn't it? Because it looks like it's something to the 3rd, something to the plus something to the 3rd, right? Number 14. F. It's something to the third minus something to the third. Number 15. Number 16. Which one's it like? E? Well, how about 17? It's something squared minus something squared, so that would be like D, wouldn't it? See how it's something squared minus something squared? Don't talk, listen. 18. It's like D too, isn't it? 19. 20. So I've basically told you which one of these rules to look at for every one of them, haven't I? And do you see how we looked at the form and tried to figure out which one it could possibly fit and then use our rules? I know this looks very daunting and very complicated, agreed? But since we broke it down, you just have to see how it fits and find A and B. Okay? Your assignment is obviously numbers 1 through 20. And obviously I expect